Is climate chaos due to a failure of policy, a lack of attention to science, or a combination of both? Climate One conversations feature all aspects of the climate emergency, the individual and the systemic, the exciting and the scary, people who are in power and disempowered. I'm Greg Dalton. After months of dealing with a volatile political climate, it's easy to overlook the actual climate and how it's impacting our daily lives.
Now, deep freeze is hitting large parts of America from North Dakota to Texas, forcing energy suppliers to institute rolling blackouts. That's in an attempt to prevent the collapse of power grid networks.
While Texas recovers from an unusual polar vortex, California is preparing for another year of intense drought. And Wall Street financiers are moving their remote work to Florida, which is ground zero for flooding and sea level rise.
Places like South Florida are up there with so many major human settlements right on the water's edge, where these questions of how will we get from where we are right now to a world that is resilient and safe with that amount of climate change.
Katharine Mach is Associate Professor of Marine Ecosystems and Society at the University of Miami and an expert explainer about the connection between extreme weather and global warming. We'll hear from her later in today's show. First, about that brutal cold.
We had a compound event because we had extreme cold that created its own public health issues. But then we had freezing roads that caused traffic issues. And then we had a power breakdown. And then we had water loss. So that's a multi-compound event there.
Marshall Shepard is the Georgia Athletic Association Distinguished Professor of Geography and Atmospheric Sciences at the University of Georgia. He's noticed 3 things that most people get wrong about climate change and the polar vortex.
You know, I was doing quite a few interviews with the media, and one of the things that I noticed is this idea that the polar vortex is something that comes to get us like a storm or a tornado, when in fact the polar vortex is essentially always there. It's this sort of fast-moving river of air up near the Arctic that's circulating around the pole. What happens is at times it gets disrupted or weakened, and then you get cold air oozing or spilling into the lower 48. So it's not this storm or Arctic hurricane or Arctic tornado that comes to get us. It simply is a dynamic feature of our atmosphere on a rotating body. Other planets have polar vortices, by the way. So that's one thing that people get wrong. The other thing that people get wrong is they talk about polar vortex and climate change, and there's some misconceptions. Is this caused by climate change? Was the cold event and the Dallas power outages caused by climate change? And I don't like to use that framing. I co-authored a report for the National Academies of Science a couple of years ago, and we talk about that we need to get that out of our dialogues and talk more about that events like that are more likely or become more intense or frequent because of climate change, because I can't identify the 368th home run that a baseball player using steroids, I can't identify that 368th home run was caused by steroid use, but I can certainly look at his statistics and the length of his home runs and number and see that there's steroid use. And so that's how we talked about sort of framing that particular argument. And the third thing that I often talk about is that, you know, we're going to have winter all of the time because we live on a planet that's tilted and rotating around the sun. So when we're tilted away from the sun, we get cold air. And so we'll have these cold events, and they will happen from time to time. We have to understand how the anthropogenic climate change that we certainly are experiencing on this planet interacts with our naturally varying climate system.
And one NOAA scientist calls the polar vortex like a chain link fence containing a group of animals, and some of them escape sometime. How is climate change affecting that fence that at the top of the world?
Well, it's an emerging area of research in climate science. But the idea is that people like Dr. Judah Cohen and others, Jennifer Francis, who've studied this more closely than I have, there's some indication that we're seeing these extreme outbreaks of cold more frequently. It seemed that they happen every other year or so, but in recent years, they seem to be happening every year. And there's been some scientific studies that link that to a sudden warming in the stratosphere. We call them sudden stratospheric warming events. And these sudden stratospheric warming events, through some complex dynamics, lead to a weakening or a disruption of that polar vortex. And so when it is weakened, it is like that chain link fence being breached, and all the little dogs or cows or sheep run out of that little opening in the breach. Well, when it completely breaks through, then they can all spill out. And that's kind of the analogy to this cold air. It's kind of fenced into the Arctic. but once it breaches, that cold air can spill into the US with these sort of high amplitude jet stream patterns. So to me, the way I explain this to my students is that, I spent 12 years of my career at NASA as an Earth system scientist before going to the University of Georgia. And we think about the Earth as a system. And so we can't understand climate change unless we understand changes in the Arctic or in these ocean circulations or in the biosphere or the green ocean, the Amazon, and so forth. So it's just one of those sort of complexities of the Earth system that we're candidly learning about on the fly. I don't know if that's good or bad. It could be dangerous, actually, but there's so much that we're still learning because we now have observing systems from space, satellites, submersible systems, Argonaut systems, so forth, that can tell us more about these things that we didn't have 30 or 40 years ago.
Another complex system is the human brain, and unregulated electricity markets in Texas contributed to a grid that was not weatherized to standards required by the Texas legislature. And coastal Americans have had fun snickering at Texas the last couple of weeks. But there's a broader point about humans not being very good at calculating extreme weather risk that goes beyond Texas. What does the Texas debacle illustrate about the optimism bias?
Yeah, it's something we deal with in weather and climate quite often. Optimism bias, recency biases, and so forth. I see it all of the time whenever we had 30 named storms in the Atlantic hurricane season this year. And that comes to mind because you always have people that say, oh, I've lived through 3 hurricanes. I'm not leaving. I can live through this one again. And that's an optimism bias. And because you probably haven't lived through an anomaly event. I heard people in Houston after Hurricane Harvey saying, yeah, I was caught off guard because we get floods all the time. It rains a lot in Houston. Yeah, but you don't get 50 inches of rain in 4 or 5 days. That's an anomaly event. So people's optimism biases don't prepare them for anomaly events. And so this cold event that we saw in Texas, though it wasn't unprecedented cold, we've seen that level of cold before, it's still rare for them. So it's an anomaly to them. And so they weren't prepared. Now, the weather forecasts were spot on. We knew days to week in advance that was going to happen. And so there certainly should have been a bit more preparation. I always say these days that their hope or waiting and seeing is no longer a valid risk mitigation strategy. That just doesn't fly anymore. Our weather forecasts are too good. But some of the preparation needed for our natural gas and our wind turbines and our water supply infrastructure require long-term planning. They're not things that can be done in a week or 2 weeks. We need to sort of think carefully about resilience and what type of investments we as a jurisdiction or a city or a state or a nation are willing to make under the notion that we will experience new normal events that are going to test our infrastructure.
Yeah. As Texas was freezing, I was reminded of the epic wildfires in the American West last fall, with millions of acres on fire and electricity being shut off, businesses shuttered, food rotting. Fires don't typically cause power outages hundreds of miles away. You write about such compound events. How can we get our heads around multiple systems going haywire at the same time?
Yeah, this compound events, this is something I testified before the House Science Committee in Congress in 2019, and there was a lot of interest in these compound events. Now, compound events are defined differently by different scientists, but the way I use the term, I am talking about this event that we just saw in Texas. We had a compound event because we had extreme cold that created its own public health issues, but then we had freezing roads that caused traffic issues. And then we had a power breakdown, and then we had water loss. So that's a multi-compound event there. Same thing with the fires, same thing with hurricanes. Hurricanes are compound events by their very notion because they bring destructive wind, but then you could have flooding and storm surge issues that linger for a day or two, but then you could have public health or disease related issues from waterborne disease in that standing water for days after the hurricane. And so I think this is something, as I'm messaging to policymakers and stakeholders, not only do we need to be thinking about these climate related disasters and extreme weather events that are upon us and will continue to be so, we need a fundamental planning, policy structure, and emergency response structure that understands the likelihood of more intense and multifaceted compound events.
Right. I mean, it's amazing because I had a friend in Austin who there's no water. You can't flush the toilet. I mean, there's just like one thing after each one of those is bad, but you got three of them on top of each other. It's really, really tough. Meteorologists on local TV are one of the few figures that progressives and conservatives both will still watch in this country, yet they're often reluctant to mention climate disruption while extreme weather events are happening. You've co-authored reports on attribution of climate to severe weather. What are local TV weathercasters doing in terms of talking about climate? Are they doing enough? Should they do more in real time?
Well, I think we've come a long way with that, because even 5 years ago, if you'd asked me this, I'd say there's still a real problem with the number of TV meteorologists who are the only scientists that most people see every day.
Right.
They don't talk to folks like me. But 5 years ago, I would say, there's still a problem with a lot of that community either being in denial or skeptical of climate change, or just being unwilling to talk about it because they're worried about ratings or their own understanding of their ability to explain it themselves. But data from the American Meteorological Society journals that I've read and papers I've reviewed coming out of groups like George Mason University and Ed Maybach and the folks at Yale suggest that the needle has started to move. More and more TV meteorologists are increasingly talking about climate change. And this notion that it will harm ratings in conservative areas, for example, has never been true, because some of the most effective TV meteorologists that talk about climate change, when I think about people like John Morales in Florida, or Amber Sullins in Arizona, or Jim Gandy before he retired in South Carolina, these are very conservative states, but they talked about climate change and they were the leading TV meteorologists in their markets. And so that they disproved this idea that you can't talk about climate change. Mike Nelson is a meteorologist in the Denver, Colorado market that just released an outstanding book about climate change, a little simple book, very consumable, readable by the average person. So I think we're seeing the needle move. I will agree that I would like to see a bit more sort of discussion about sort of real-time sort of implications related to possible climate change or attribution. And I think we'll get there. I think organizations like Climate Central and the information that they feed out to TV stations is helpful. And I think there's some other organizations that are emerging that are helping in that regard too.
I think the next frontier, if you think about the structure of local newscasts as kind of the latest crime, and then it goes to sports and weather, the next frontier would be to get the sports journalists to talk about it. I thought about that when the NHL held an outdoor hockey game near Lake Tahoe in the Sierra Nevada in California, and they had to stop it because the sun, this is February, the sun is so hot, it's melting the ice outdoor, right? And it wasn't safe to play on. And climate is affecting sports. It's affecting tennis tournaments. It's, you're the Georgia Athletic Association Distinguished Professor of Atmospheric Sciences, University of Georgia. You know this.
Yeah, it's funny. I just hosted a podcast for the Weather Channel, and we interviewed a colleague of mine that's on the Olympic Committee's weather planning committee as they're thinking about the Summer Olympics in Tokyo. And the heat, that's going to be one of the hottest places that we've seen an Olympic event, set of events. And there are some concerns about the heat there and other things. So, climate and weather literally are one of those things that touch everyone's lives. That's why everyone talks about weather and climate. And that's why, candidly, sometimes me as an expert in weather and climate get opinions from people who aren't experts because they feel they know weather, they live weather, they experience weather. And so I guess because of that, they feel that they can offer their opinions on forecasts and climate change. I get opinions in the mall or at the local fast food place that I'm sure no nuclear engineer ever gets from someone walking up to him leisurely.
You're listening to a Climate One conversation about science and climate chaos. Coming up, implicit bias and systemic racism in the hollowed halls of science.
I had a former student of mine tell me flat out, he said there was a faculty member at his old university who said, Marshall Shepard is exceeded because of his color. That's not the case when you go back and look at my contributions.
That's up next when Climate One continues. This is Climate One. I'm Greg Dalton, and my guest is Marshall Shepard, Professor of Atmospheric Sciences at the University of Georgia. Dr. Shepard is part of a new research effort in Atlanta exploring the connections between race-based segregation and increased exposure to harmful heat in communities of color. He explains what they're hoping to understand.
Well, first of all, I'm an African American scientist, and I've had my own sort of experiences in that regard. I would like to share that I wrote a book in 2020 called "The Race Awakening of 2020: A Six-Step Guide for Moving Forward," and I didn't write that from the lens as a scientist. I wrote it from the lens of a black man in this country that has a black son and watching the George Floyd incident. And so I was just very concerned about it. And so I had white colleagues, I had colleagues from other races saying, well, what can we do? This really is an awakening for me too. I haven't really focused on race as it relates to weather and climate much of my career. Most of my career focuses on things like extreme precipitation, urban climate, hurricanes, and risk vulnerability, and so forth. But in recent years, one of my areas of expertise is urban climate. And, I'm well versed in this notion of urban heat and urban heat islands and distributions of heat and where people live. There was a study that came out last year that suggested that historical redlining associated with discriminatory practices in lending and insurance and so forth had created these places in cities where marginalized populations are more likely to be exposed to heat. And you got the double, sometimes triple whammy of heat because you have the urban heat island, and then you could have during the summertime a heat wave, and then the broader warming associated as climate changes. And so there are people we think and hypothesize are disproportionately exposed. And so we were funded by the university through a series of race-based scholarship that they funded to look at this. And so we have an urban geographer and a GIS specialist and me, an atmospheric scientist, that will look at sort of, how race is distributed in terms of housing and populations in the city of Atlanta and surrounding areas, and whether there's a sort of disproportionality in terms of how they're exposed to heat.
And urban heat island, we should maybe explain that. That's the idea that there's concrete and asphalt that absorbs and radiates heat, and there's fewer trees in these neighborhoods, right? Did I get that right in terms of there's less shade, more surfaces that absorb and radiate heat?
You got it right. But I'd add to that, it's not that it's just less shade. Because cities tend to have less trees, there's less evapotranspiration as well. Evapotranspiration, like evaporation from our skin, cools the air. And so when you have less evapotranspiration, there's less cooling in that process, in addition to the radiating surfaces like asphalt and concrete. And then there's another term, which we call the anthropogenic heat term too. You ever stood by as a bus goes by, you can feel the heat associated with the engine or the bus as it goes by. So these additive terms lead to this sort of disproportionate heating anomaly or urban heat island in cities compared to suburban and rural areas. And so that's exactly what we're talking about. And like I said, we want to investigate how people are distributed in the Atlanta and surrounding areas as compared to the heat island signature that we can measure from observations we take with meteorological instruments or even from satellites.
I was flying into Portland a while back and saw white roofs all over the place. That's one of the responses to that effect, is to bounce the heat back rather than absorb it on the rooftops. You were the first African American to receive a PhD from the Florida State University Department of Meteorology, one of the nation's oldest and respected. You were the second African American to preside over the American Meteorological Society. What were some of the biggest obstacles you overcame breaking into scientific circles dominated by bearded white men?
Well, the biggest one came in when I was a child. I mean, I was always interested in science, particularly weather, but there were no scientists. I just spoke to a young man this week via Zoom about his interest in our field. I didn't have any of that. I mean, there were no scientists that I felt like that I could have access to or reach out to or even resembled me. So I just
Neil deGrasse Tyson wasn't out there yet.
No, and no, he wasn't, and even still, he wasn't in weather and climate. But so I just read books about Dr. George Washington Carver, who is an outstanding scientist that did a lot of really, really neat things with peanuts. So that was an initial challenge right there. As you get a little older and you go through, you start to, and this is still a big challenge for young scholars, African American and people of color. You sort of have to deal with this notion that, oh yeah, he's there because he's black, or he took my job, or he really doesn't deserve to be there. And there's this innuendo about why are you a scientist at NASA, or how did you become this, or how? So you always know that underlying thought is there in some people's mind, not all.
Does that mean you have to be better? Do you have to be better to?
You don't have to be, but I think there's a chip on your shoulder to be. I think that's a, an unfortunate byproduct that many of my colleagues feel exactly that way, that they have to be better because, look, I had a former student of mine tell me flat out, he said there was a faculty member at his old university said, "Oh, Marshall Shepard has succeeded because of his color." That's not the case when you go back and look at the fact that I've published over 100 publications and have been recognized at the White House and the Fellow of the American Meteorological Society on my contributions. But that's out there. I mean, I wrote an article in Forbes. This climate skeptic thread was out there on email, and one person on that thread decided to email me and complain about something I wrote in Forbes, but he forgot to remove the entire email thread. And so I was able to see some of it. And in one of the comments, it said, "Oh yeah, Marshall Shepard is the token Black that's using climate change to advance his career." And so these were people that I walked the halls of conferences with. I knew several of people in that thread. So and they don't know I know, but I do know. And so I carry that with me. So those are challenges. As president of the AMS, I was standing in the conference hallway of the hotel conference, lobby of the hotel where the conference was being held, I should say, with 3 or 4 other former presidents of the AMS, and the woman comes up to me and asks if I was the airport shuttle driver because we all had suits on. And so there's that very explicit thing, and then there's the microaggressions that I write about actually in my book, where people come up to me and say things like, "You're such a credit to your race," or "You're so articulate," or "You speak so well." After that lecture, talked to many of my colleagues that said, "I've come off stage and never had anyone tell me how articulate I was, or why do I need to be a credit to my race?" And so those are out there. They're gender-based microaggressions. They're microaggressions from many different perspectives. So it's one of those things that I wrote about in the book so that people are aware of them, because a lot of times people are doing them thinking they're paying you a compliment, but they're actually backhanded microaggressions.
Climate's getting a lot more attention now. The Biden administration is looking at every policy issue through a climate lens. How are you feeling about the prospect for meaningful progress on stabilizing the climate now? There seems to be sort of an upswing. I'm wondering if you're feeling as optimistic as I am.
Well, it's interesting. I might have a different take on that. Yeah, I clearly see that the Biden administration is going to attempt to move the needle at the federal level. And we're coming out of sort of a dark period of the last 4 years where we pulled out of the Paris Climate Agreement and EPA was under attack and so forth. But the reason I say I might have a slightly different perspective is that even in the last 4 years, I was still encouraged by the activity that I saw at state and local levels, from faith-based organizations, from the private sector. So I would often tell people that even though things look bleak in the federal sector, there are a lot of good things that are happening. Drawdown Georgia, Project Drawdown, a lot of different things that are happening that were good, even in the midst of that federal chaos that we saw in the last 4 years. So what I'm optimistic about is I think the Biden administration is going to continue to keep climate as a front and center issue. They are thinking about climate in a cross-cutting manner. So you won't see this administration just talking about climate in the science agencies like NOAA or EPA or NASA. They're thinking about climate from the perspective of the Department of Agriculture, Housing and Urban Development, and Health and Human Services. So they understand the cross-cutting nature of climate. And I think that's one thing that's going to be a signature of the Biden administration that I'm quite pleased with. I think they're going to really think carefully about the equity issue. We'll probably try to move the needle on renewables a bit more than we've seen in the past. And protect our federal lands and from things like drilling for oil and things like that. So there are certainly things to be excited and optimistic about. But I think there were some hints of optimism that may have been missed at different levels as we were so dismayed by what was happening at the federal level.
Marshall Shepard, Georgia Athletic Association Distinguished Professor of Atmospheric Sciences at the University of Georgia and host of the Weather Geeks podcast. Thanks for coming on Climate One. It's a pleasure to talk with you. I feel better. I feel appropriately afraid and appropriately optimistic at the same time. So thanks for sharing your insights today.
Hey, thank you for having me.
You're listening to Climate One. I'm Greg Dalton. As Dr. Shepard notes, microaggressions and other unconscious displays of power and privilege can take many forms across the scientific disciplines.
One of my students said to me at one point that she feels like she doesn't really have to worry about these issues because she knows I have her back. For me, those types of moments are where it really feels worth it.
Katharine Mach is Associate Professor of Marine Ecosystems and Society at the University of Miami. She co-directed the IPCC Working Group on Climate Impacts, Adaptation, and Vulnerability. Our conversation began by addressing a different kind of aggression, namely the Trump administration's open hostility to science, and what effect the last 4 years have had on climate data and science.
There are a few different layers here. So first of all, there are places where climate science has proceeded, but it hasn't necessarily referred to climate change as directly, right? If many of the aspects of responding effectively to a changing climate, understanding what's happening, come down to weather that is changing through time. In the current era that we've gone through, some of that has meant that instead of being about climate change, some of the same research has proceeded more with an emphasis on its relevance to weather. I think there are a lot of ways that federal agencies have not been unleashed to their full scientific capacities. I think there's a relevant parallel with the pandemic. You could say before the pandemic occurred, the US was at the top of the global rankings for preparedness to respond in a pandemic, which is all about science, federal institutions, and policy coming together. We did not deliver on that. And I think there's a real parallel there for what it's meant for science in our federal agencies. And then those science questions, they interact with the policy questions, but I do think that policy question has been where much of the backsliding has been unambiguous and stark.
The Biden administration wants to pass a big infrastructure bill. We've heard about infrastructure as the area for bipartisan agreement for quite some time. As an expert on coping with climate risks, how should the administration think about rebuilding America's bridges and roads in a climate-smart way so the money is wisely spent?
Wonderful question, and one that I think about a lot, especially thinking about infrastructure, for example, in South Florida, where the risks from sea level rise are real time and also pronounced over the decades to come. There are a few different entry points. One is the degree to which our preparedness for a changing climate comes down to our current starting points. So where we've got infrastructure in disrepair, levees ready to fail, roads that aren't where they should be, all of those mean that the challenge for ensuring preparedness as the climate continues to change is even a bigger challenge. Then there's the next challenge of many of the major infrastructure projects occurring now or in the next decade may well have lifetimes of many, many decades. And especially for something like sea level rise and the instability of the ice sheets, where there are just really important uncertainties there, the question for infrastructure is not necessarily planning for what will be the most likely future, in that robust planning is, will that infrastructure, whether it's a road or a bridge or a septic system, still function across the full range of possible climate futures that we might see over the decades to come?
Right. I remember talking to the person responsible for protecting downtown San Francisco, where there's a seawall that is not earthquake safe. And she said, no scientist can tell me how high, by what year we should build the seawall to protect $100 billion in property downtown San Francisco. And I thought of it kind of like Lego. You have to build a seawall where you can add another row of Lego on top of it, as the seas rise, because it's so uncertain. But people making decisions need to know, how high do we build the seawall? How high do we raise that road? Right. And it's hard to say.
I love the Legos analogy there. So I think the scientific counterpart to Legos has been an increasing emphasis on methods that are all about making good decisions in the face of uncertainties that exist. And, the future is always uncertain. Which school does a kid go to? Does a couple get married? Which house do they buy, right? These are all decisions under a lot of uncertainty. And so the fact that climate change involves uncertainty really isn't unique to climate change. And the really cool thing is that means that good science for decision making is about the methods through which that science can inform decision making. So kind of the scientific counterpart to Legos, you could point to something like adaptive pathways. So the Thames barrier protecting the City of London is one of the first pieces of infrastructure globally to have this pathways approach be developed. And the basic idea is that it's pretty hard to say exactly when the world will see 2 additional feet of sea level rise, or 3 or 4. All of those numbers are very likely under many of our possible climate futures. It's a question of when that would occur. So for something like the Thames Barrier, or you could say downtown San Francisco, what you might want to do, instead of pegging it to the year at which a given amount of sea level rise would happen, you would peg it against the amount of sea level rise that's happened. And you also know, if you go from the current height and add your layers of Lego seawall, as in you extend the seawall, how long does it take to make that adjustment? And are there any adjustments that would create a path dependency where it's hard to reverse them? And so the pathways approach is basically saying, where do societies want to go? What is a regional priority for responding to sea level rise, for example? And what are ways that as sea level rise continues through time, preparedness options are all about making sure we're responsive to the amount of sea level rise that does occur, recognizing that right now it's very, very hard, truly impossible to say exactly how much sea level rise will happen a century out, for example.
What are some other new advances in climate science that you find intriguing? What are some new science breakthroughs or things that people might not know about if they don't read scientific journals?
So one has been, as climate change increasingly is not something hypothetical far off in the future, but something where we're seeing, whether it's smoke from wildfires or the amount of rain that comes down in a storm, we're seeing intensification of risks right now. And oftentimes, what's really hard to manage in real time is not necessarily the most direct aspect of just how much water enters into the system. It's the cascades. It's, does the road system get blocked? Does your communication system go out? Have you had to drop power on the lines to prevent the outbreak of a wildfire or to respond to heat simultaneously? And those cascades, that complexity increasingly is squarely in the space of science as well. So a lot of the physical climate science is saying, okay, let's not just study heat, temperature in isolation. It's important to recognize that the impacts of heat are often heat and humidity in combination. So putting those together, for example, or that it's not just a question of a hurricane coming on shore. It's what's the storm surge associated with that? Is it on a high tide? How fast is that storm moving? So oftentimes this complexity is increasingly coming into the space of the physical climate science and then absolutely the impact science. And so that kind of comes back to what we were talking about in terms of science relevant for society. That complex part of climate risk is really crucial to what people have to deal with when something goes wrong. So a lot of the science is actually figuring out what is the status of human response to the changing climate. And that's stepping far from straight physics all the way through the human experience of the changing climate.
So what's the headline there? Is humanity getting ready? Are we kind of doing the kind of insulation preparations? We know that we weren't where we were prepared, but didn't do so well on COVID. How are we doing? What's the scorecard?
There is a lot of planning happening. There's a lot of early stage action, but in terms of actual adjustments being made, they are underwhelming. And I think in the US, we can say this is pretty intuitive. The number of billion-dollar disasters that we experience in any given year has gone up over the decades past. It's not something where we've really turned the tide on damages from climate and a changing climate. But the neat thing is by actually being able to say, most action we see globally has been surprisingly kind of around the edges and incremental, creates a really crucial starting point for making sure that investments moving forward increasingly push towards more fundamental improvements in just how prepared we are for the changes in store.
So it sounds like, on the adaptation side as well as the mitigation side, things are going in the right direction. Steps are being made, just not fast enough and not on the scale that's necessary.
Scale and speed, exactly.
You're listening to a conversation about science, policy, and society. This is Climate One. Coming up, bringing science back into national government.
I think it's really important to recognize that these will never be separate spheres. There will always be values and some level of politics in science, and vice versa.
That's up next when Climate One continues. This is Climate One. I'm Greg Dalton. My guest is Katharine Mach, Associate Professor of Marine Ecosystems and Society at the University of Miami. We're talking about the intersection of science and climate policy. The Biden administration recently announced it will look at climate impacts on human migration, a topic Katharine also thinks a lot about.
First of all, it's important to recognize that movement in a changing climate takes a bunch of different forms. So one would be, disaster displacement. I think all of us in the United States know the example of Katrina and the pronounced displacement that in many cases became very long-term or permanent. So those types of disaster displacement, are they temporary? Are they permanent? That's one form of the way that a changing climate affects the movement of people. Another one at the other end of the extreme would be deliberate decisions to abandon areas that flood again and again, that are eroding into the sea, that are washing into the sea as ice melts, permafrost thaws. And that space of retreat is also in this spectrum of movement in a changing climate. So when we say, how does climate affect migration or movement of people, it's really important to recognize that some of that's in the space of disasters, some of that's the slow burn effects. If an area gets drier and drier and more desertified through time and crops can't grow as well, a lot of those are open questions for the future. But I think what we know for sure is that climate already is entering into the suite of factors that influence movement from displacement to migration to retreat. And increasingly into the future, the numbers get a lot bigger, whether it's sea level rise, where that geographic footprint is so clear, or fire, where the risk tends to be uneven across very large swaths of territory. And they're really important questions as to the ways in which the changing climate will intersect with local livelihoods, the safety of housing, risk perceptions, and when people will decide they'd prefer to be elsewhere.
Speaking of migration, you recently moved to the front lines of climate in Miami. How did you feel moving into the eye of the storm, knowing what you know about what's coming to Florida?
I mean, given that I focus on resilience and preparedness for the risks of a changing climate, it wasn't an accidental choice. And honestly, it's been just incredible. I mean, it is a region where climate change, sea level rise are in the current day. And it's not just something where the scientists see the issues in the science. These are floods that happen on the high tide. Art. Miami has a vibrant art scene. It's something where, you can say the yard signs that are about the risk of flooding, to your front door. These types of interactions are just really, really powerful, and one where the research I do can be very much in collaboration with the local governments, the community-based organizations, and the passionate young students who are very interested in making sure their research is actionable for all of these ongoing decisions.
Wall Street bankers are also moving to Miami. A number of high-profile financial firms and billionaire investors are setting up shop in Miami. Are there climate risks to property and human well-being any higher there than Manhattan? When I first heard about that, I was like, oh, God, these are smart people. They're going to a risky place. Do they know what they're doing? Well, maybe it's not as risky as I might think.
Oh, yeah, no, it's interesting, and a theme where actually in the space of, long-term risks and viability and, what will the long-term game plan be, there are some important differences between Miami and Manhattan. You could imagine the New York story of adapting to sea level rise being one of rolling the city inland, for example, among many possibilities. Whereas in Miami, rolling inland isn't going to do it because sea level rise is very active on all sides of the metropolitan greater Miami area. And so, yes, in Miami, there are billions of dollars of assets within 3 feet of the current high tides. There is a big effort in putting together the pieces of yes, keeping out storm surge, but recognizing that with a porous limestone bedrock, the water comes in through below, so to speak. And this is about the viability of septic systems and roads that are increasingly submerged and cars that are increasingly exposed to salty water, and a world of continued high emissions of heat trapping gases, really could mean 4, maybe 8+ feet of sea level rise in the century ahead. And in those types of worlds, places like South Florida are up there with so many major human settlements right on the water's edge, where these questions of how will we get from where we are right now to a world that is resilient and safe with that amount of climate change, those are some of the major open questions.
The election of Kamala Harris as the first female vice president is a huge milestone for gender equity in politics and has put a spotlight on the issue in other arenas. You wrote an article about women in science when you were a PhD candidate and drew on your experience as a girl playing Little League on all boy teams. What was that experience like for you, and how did it inform your career in science?
Yeah, no, a question that I've been thinking about for a lot of years now. And I guess I would say for me, it was in graduate school where I suddenly realized, wow, there aren't all that many senior women in many forms of natural sciences, especially. And what was funny for me is once I realized that, it was kind of like a ding, 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 ding. So many things came into focus where I realized, in all of my undergraduate classes related to my major in biology, I'd had 2 female professors out of 18. And I'd never even noticed that that was the ratio. And it was suddenly at the point where I was thinking about my own career in a longer term sense where it jumped out. So, being rather academic, I just started reading and obsessively reading. It was so fascinating. And oftentimes that was what I would read late at night rather than the stuff relevant to my dissertation for sure. And I think what the numbers suggest is that, the pipeline for a long time has been very leaky. The number of women at the PhD level does not translate for decades now into the number of women in senior faculty positions, leadership positions. I think for me, what was so profound about really looking into what the data say about women in science was, first of all, very quickly realized that this was not at all confined to an issue of women in science. The barriers for people of color are even more stark. There is not a very open culture in many natural sciences in particular around LGBTQ plus students. Issues of inclusion are really multifaceted. And as I kept reading, it was like, wow, what did I do picking a career in science? But then at some point I realized actually these are the same dynamics in so many professional realms. And in this weird way, almost going full circle, saying I started with women in science, thinking broadly about who's in the academy and why and what their experience has been, and recognizing finally that, oh, this is happening everywhere, in a weird way was very empowering, and one that I've really carried with me and recognized that increasingly through the course of my career, as I get older and older, I have more abilities to shape the experiences, the system-wide dynamics for those who come behind me. And one of my students said to me at one point that she feels like she doesn't really have to worry about these issues because she knows I have her back. For me, those types of moments are where it really feels worth it.
And on the Little League, when your experience playing Little League as a girl in all male teams, you led the league in doubles, but also had a more dubious honor. What was that? I mean, was it intentional? What do you take from that? Did you apply to academia? Because, what do you take from that Little League field? And tell us what that honor was.
My dubious honor was I was hit by more balls from the pitcher that skewed off course and struck me than anyone else in the league. And it was kind of this funny experience where, I could almost kind of feel that being the only girl on the field could understandably make a pitcher nervous. And for me, I think the interesting connection there to draw to my experiences as a scientist is actually how so much of what goes on in terms of inclusion for women or people of color can be unconscious. These kind of implicit biases that we all carry. I know I carry biases against other women in science, which feels crazy, but you can take these implicit association tests and realize that most stereotypes that exist as a social phenomenon in our societies, we tend to internalize unconsciously, and they affect the types of judgments we make. So an inclusive environment is one that's responsive to, yes, the official policies in place, but also an environment that is one of mutual respect. So these types of little accidental microaggressions essentially aren't a dominant part of the experience.
The pantheon of climate science is the IPCC, the Global Group of Climate Scientists, which has only been led by men. You've worked at a high level within the IPCC. How male dominant and inclusive is that culture?
Yeah, there are a lot of different angles I could take on this question. It's definitely one I've thought about a lot. I mean, I think in a simplistic way, you could say, as you go from the lead authors, the bulk of who shows up to the science team, to the coordinating lead authors, to the co-chairs of each working group, to the chair, it's a little bit of a pyramid where there historically have been fewer women at every rung. So that's an unambiguous part of it. I also think that for the IPCC, the global context of who's at the table is really pronounced as well. So as a woman where English is my first language and I've been embedded and fully funded to do climate change science at top tier universities, recognizing that I actually had a lot of privilege in that context, and that the questions of inclusion in a context that is so global go far beyond gender, even though gender is an important part of that. I think, in a way, some of the aspects of the governmental side of the IPCC for me were really inspiring, in that it's an environment where it's about consensus, it's about hearing all voices, and you might be hearing those voices all through the night, multiple nights in a row during those government approval processes. But it's really a remarkable example of the diversity of perspectives really mattering on these issues.
Bill Gates is out there talking about climate these days, and one of his main points is stabilizing the climate will require unprecedented collaboration across disciplines and national boundaries. Do you think men are as good at that? Do we need more women to do that? Can we count on the men to do that kind of collaboration that hasn't happened before?
A lot of angles here. I mean, I guess one question and distinction would be the science underpinning for societal actions and then policy itself. And I think making sure there's diversity in both of those groups is crucially important. For the science side, why can people trust science? It's when it's a whole lot of perspectives, diversity inherent, open to criticism, open to revision and peer review and improvement of that understanding through time. So in that case, if it's only a few people asking the questions, we can be pretty sure they won't be asking all of the relevant questions and bringing in the full suite of disciplines, for example, that are relevant. On the societal side, I think it's an issue of climate being something that affects basically all communities and all countries on planet Earth. And if you're only tapping 50% of brain power, you're certainly missing out on the capability side of things, but also what it means to have messengers in the space of policy that resonate with all communities. And if you're narrowing your group of leaders and messengers and scientists, we're not going to get everyone at the table working together full force ahead, which is what we really need in the climate issue.
And mentioning the disciplines, the climate conversation is anchored in chemistry and physics, but the behavioral sciences such as psychology and sociology are also coming into play as societies grapple with changing human behavior. Do you think social science gets enough attention in climate conversations and funding?
I think we're at a point right now where there is clear understanding that the basics of climate science have been understood, frankly, for decades. You could even argue more than a century. And we're not necessarily seeing deep attention to responses, or we're seeing growing momentum, but not necessarily enduring change in line with what's necessary to keep people safe. And so all of those complexities are about the human side of the picture. How are the risks of a changing climate perceived? Why do people move to a location that's within 1 foot of the high tide watermark? Some people don't care about those risks. That's actually environmental psychology more than it is necessarily a strict sea level rise question. Governance, political science, environmental justice, these are all very, very real aspects of how societies choose to respond in a changing climate. And I think to your point about are the social sciences getting enough attention in climate conversations and funding? Some of the major federal mechanisms for funding climate research are increasingly focusing on connecting disciplines and connecting science with society and doing it really, really well, such that it's not just something where you would say, scientists, was this a cool science experiment? Did you have a major breakthrough that you published in Nature? But instead, it's about partnerships in the research process where the full set of experiences of the partners in government or nonprofits focused on social justice are evaluated as much as the perspectives of what the strictly speaking scientific outputs were. So that is starting to change, and I think it's something that is here to stay.
Katharine Mach is Associate Professor at the University of Miami. Thanks for coming on Climate One.
Thank you so much, Greg. Really nice to talk with you.
You've been listening to a Climate One conversation about science, policy, and society. You can hear more by subscribing to our podcast on Apple, Spotify, or wherever you get your pods. Please help us get people talking more about climate by giving us a rating or review. It really does help advance the climate conversation. Kelly Pennington directs our audience engagement. Tyler Reed is our producer. Sarah Catherine Coxon is the strategy and content manager. Steve Fox is director of advancement. Devin Strolovich edited the program. Our audio team is Mark Kirshner, Arnav Gupta, and Andrew Stelzer. Dr. Gloria Duffy is CEO of the Commonwealth Club of California, the nonprofit and nonpartisan forum where our program originates. I'm Greg Dalton.